Hi guys, this is Ashraf Chiwal. Last time I talked about strategy as design and why it's not good in a very complex and uncertain world. And I ended the video by saying that despite knowing exactly the rules of the game, strategy wouldn't work either. And this is because of computational irreducibility. So what does that mean? Computational irreducibility says that you can't reduce a process in simple steps. You need to go through those steps one at a time. In other words, if you want to go from point A to point Z, and you know exactly how to go from point A to point B and from point B to point C, and so on and so forth, you wouldn't get to the point Z. And this is because unintended consequences emerge along the way. And this is what Stephen Wolfram came up with in his groundbreaking work 20 years ago, New Kind of Science. So, and this has a far-reaching consequences in everything we do in life and business. Now, lately, Stephen Wolfram updated his theory by saying, within this computational irreducibility thing, you can still find pockets of computational reducibility in which you can predict things. The point is to try to identify where those pockets lie. So, how computational irreducibility and pockets of reducibility can be used in business? That's a great question. I do believe that this has to do with three things. First is the scale. I mean, what I mean by scale is the number of agent, number of people, number of units involved in a thing. Second is time. And third is the number of rules to be applied. So let's work out a simple example. If I want to go downstairs and get a cup of coffee, the level of uncertainty is quite low, very low, and the unintended consequences are close to zero. But if I organize a group of people to go source the coffee overseas, getting it chipped, torrefied, grinded, brewed, so I can get my cup of coffee, I am increasing the scale, which is the number of people involved. The second thing, I'm increasing time. And third, I'm increasing the number of things to be performed. And this explains why longer projects have always unintended consequences, despite knowing exactly what needs to be done. So, strategy. So, what's the implication of all that on the way we conduct business? So, here are a set of principles. First, we need to recognize that no matter what we plan for, things will always get derailed. And the level of derailment is a function of scale, time, and the number of rules. Second, we can still plan for small scale short term projects within a very limited set of rules. This is how we put complexity in a very manageable way and decrease the likelihood of uncertainty. Third, sometimes things, endeavors cannot be performed within the first two principles. So one should play with those three factors in order to decrease the likelihood of computational irreducibility. One example is what Professor Flibier talked about in his book, How Big Things Get Done, which is the power of modularity. Remember my example about coffee? So that's why you have companies and you have a group of people doing separate things. Uh, One doing cultivation, another company doing shipping, another company doing the manufacturing, and so on and so forth. So here we're not trying to fight the complexity, we are working around it, we are managing it effectively. Fourth and last, sometimes one should allow computational irreducibility to take over because this is how new way of doing things emerge. This is how innovation happens. And by the way, the world as it is today is the product of unintended consequences, no matter what planning we think we can do.